Hi guys, today I'll be talking about the key features of graphs. In particular, I want to focus on rational functions. So let's see what we've got here. In this case, f of x is equal to x power k plus a all divided by x, and k is an odd integer greater than 1 and a is a negative value. We know that if the power of the numerator is equal to or greater than the power of the denominator, then we need to split it up like this. So we can say that this one is a non-vertical asymptote and the power is even because a is odd. And also we know that the vertical asymptote is x equal to 0 because the denominator is equal to x. So now let's try to see which graph will follow the non-vertical asymptote. So basically when x is approaching positive and negative infinity, so your graph should follow x power k minus 1. So it could be a parabola, for example, because the power is even. So A could be an option because you can see that the vertical asymptote is also equal to 0 as well. For B, if you try to draw the non-vertical asymptote, it's not going to follow that. So B can be eliminated. For C, again, you try to draw the non-vertical asymptote. So this part here is not approaching that asymptote for negative infinity. So you can eliminate C as well. For D, so if you draw your non-vertical asymptote and then you draw vertical asymptote, so D could be an option as well. A, so we do the same thing. So A also follow non-vertical asymptote, and also you can see here the vertical asymptote is equal to x equal to 0. So maybe A could be an option as well. So now you need to check other features like the x-intercept, for example. So if I let y equal to 0 and then I solve for x in terms of a, so now you know that I is negative, but then you have a negative I power negative 1 over k. So the x-intercept got to be positive. So that's the reason why the answer is I, because you can see the x-intercept here. So in this example, again, rational function. So this power 2, this is power 2 as well. And this one is exam 2. So you can use basically, actually in this case, so you have to factorize first. So you factorize the denominator here. You can see that both the numerator and denominator, they have the same factor x minus 3. That means when x is equal to 3, you got the point of discontinuity. It's not the vertical asymptote. Please keep that in mind. Okay? And then you want to basically you left with x minus 1 over x plus 2. So the power here are equal. So you want to split it up again into these two terms here. So that's the reason why you got an asymptote at x equal to negative 2 and the point of discontinuity when x equals 3. Note that the question did not mention about your non-vertical asymptote, but it does exist here. So this question I think is a little bit tricky. So you are given the second derivative, and you also know that the first derivative is equal to 0 when x is equal to 0. So we want to know what key features there are. So what you do is, from the second derivative, you just integrate it to get your first derivative. And don't forget the constant c here. And you know that the x is equal to 0 when x is 0. So from there you can work out your c, which turned out to be 0. So you just solve for the x to be equal to 0. So you got x to be either 0 or 3/2. So now you set up a table to include the key values. So firstly, you want the point where the first derivative is equal to 0. In this case, when x is 0 or 3/2. And you also need to put down the point where the second derivative is equal to 0 as well. So you can say from here, so when x is 0, both the first and the second derivative are 0. So maybe you have a stationary point of inflection, but make sure that you check the concavity. So you check the side of your second derivative, so left and right of that x value. In this case, you can say that when to the left of 0, your second derivative is positive. To the right, it is negative. So we do have the change in concavity. So you can conclude that this one is the point of stationary point of inflection. And then next, so when the y, the x is equal to 0 here, the second derivative is not equal to 0. Instead, it is positive. So that's why you have a local minimum. So now one thing we have not checked. So when x is 1, the second derivative is equal to 0, but the first derivative is not equal to 0. So maybe you have a non-stationary point of inflection. So just remember to check the left and the right to make sure that you have a change concavity, and we do in this case. So that's why your answer is A here. Okay, this one is exam 1. Again, you can say that the numerator and denominator have the same power. So what you can do is you can split that up. Because you say the denominator, you cannot factorize that. So you try to split it up. You can use long division, or you can just use a trick like this, because we want to cancel x squared plus 1 out. So on the numerator, you want a multiple of it. So because you got 2 over here, I just took 2 out. And inside, I've got x squared plus 1. If you expand everything out, you get 2x squared plus 2 plus 1, which is 2x squared plus 3. And that's what you've got initially. So now you split this up into two terms. And you can say that 2 is your non-vertical asymptote. In this case, it is horizontal, okay? So y is equal to. To sketch that bit there, so what you can do, you can sketch x squared plus 1 first, which is just a parabola, and then you do reciprocal of it to get this graph here. Okay, just another one on rational functions. In this case, you don't need to split it up. It's already split up into 2. And the one without the x in the denominator. So this one is your non-vertical asymptote. So that's that line there. So the question asks you to label the turning point, intercept, and also asymptote as well. So from there you can say, because you have x in the denominator, so the vertical asymptote is x equal to 0. And the non-vertical one is just that. To work out the turning point, so you find the y, the x, and then you make the y, the x to be 0. And then you solve for x. In this case, there's only one x value. And then you can find y by substituting back into here. And in this case, we do not have y-intercept because x cannot be equal to 0. That's the vertical asymptote. Now to work out your x-intercepts, you make y equal to 0 and then solve for x-intercept. So we've got our non-vertical asymptote, and then the vertical asymptote is x equal to 0 here. And then we know our turning point, and we know our x-intercept. So now you can sketch the graph.